Question 26 says a person swims at 143 degree to the river current to meet target on reaching just opposite to point on the other bank. The ratio of the person's velocity in still water to the river water velocity is. The student, let this be the river current, this be the width, let the width, the student, be equal to d. Now, it is given that the person swims at 143 degree to the river current. So this angle is 143 degree, meaning that this angle, which is 143 minus 90, so this is theta, which will be equal to 143 minus 90, that is 53 degrees. This is the river velocity. We can write down that sine 53 will be equal to VR by VSR, where VSR is the velocity of the swimmer with respect to river. Moving further, we can proceed and write down that sine 53, which is equal to 4 by 5, will be equal to VR by VSR, or VSR by VR is equal to 5 by 4. And hence for this question, the correct answer we can clearly see is option number 4. Now let us proceed to the question number 27. In question 27, two particles with their initial positions are given and their velocities are also given. It is given that they collide after 2 seconds, then we have to find out the value of A. Now dear student, the position of any particle, that is RF, will be equal to the initial position plus velocity multiplied by time. So we can use this equation. For the first particle, the final position, that is R1 dash, will be equal to the initial position 4i cap plus 6j cap plus velocity, that is 2i cap minus 2j cap, into time, that is given to be equal to 2. So this will be equal to 8i cap plus 2j cap. For the second particle, R2 dash will be equal to the initial position minus 3i cap plus 4j cap plus ai cap minus j cap into 2. This will be equal to minus 3 plus 2a I cap plus 2 j cap. Now these two positions should be same for them to collide. We can see that the j component is same, ith component which should be same as well, which means that 8 I cap should be equal to minus 3 plus 2a I cap, meaning 2a minus 3 is equal to 8, or a is equal to 11 by 2. The correct answer for this question, dear student, will be equal to option number 2. Moving on to question number 28. In this question, the resultant of two vectors having magnitudes 3p and p are respectively is root 13p. We have to find out the angle between the vectors. This student, the angle between the vectors, if it is theta, then the r square, that is resultant of two vectors, can be written as a square plus b square plus 2ab cos theta. This is the equation we'll use here. So we can write down that root 13p square is equal to 3p square plus p square plus 2 into 3p into p cos theta. So this, dear student, will be equal to 13p square is equal to 10p square plus 6p square cos theta. The p square will get cancelled out and cos theta will come out to be equal to half, meaning theta is equal to 60 degree. From the given options, we can clearly see that the correct answer should be option number 4. Now let us proceed to the question number 29. In this question, a particle starts from the origin at t is equal to 0 with a velocity of 5 j cap meter per second and moves in the xy plane with constant acceleration of 4 I cap plus 2 j cap. We have to find out the position vector after 2 seconds. Dear student, the equation that we can use is s is equal to ut plus half at square individually for ith and the jth component. In the sx will be equal to, it is given that the initial speed is 5 j cap, so the initial speed in x direction is 0 plus half into 4 into 2 square, as 4 is the acceleration in ith direction. This will be 8 meter. Similarly, in yth direction, it will be equal to 5 into 2 plus half into 2 square. 5 is the initial speed in the y direction, and this, dear student, will be equal to 14 meter. And hence the final position will be 8 I cap plus 14 j cap meter, option 2 being the correct answer. Now let us move to the question number 30. In question 30, a projectile is thrown with velocity 20 meter per second at an angle of 60 degree with the horizontal. The change in magnitude of the velocity during the time interval in which it reaches the highest point is. Dear student, at the highest point, the velocity of the particle can be represented from this trajectory. At the initial position, if the velocity is u and this angle is theta, at the final point, the velocity is simply u cos theta, that is the horizontal component. So u cos theta will be equal to 20 into cos 60, and this will be equal to 10 meter per second in magnitude, while here it is given as 20 meter per second in magnitude. We have to find out the change in the magnitude only. So the change in magnitude will be 10 minus 20, that is minus 10. Moreover, it is given that we have to find out the magnitude of velocity, and this can be represented as in positive terms to be equal to mod of minus 10, that is 10 meter per second. And hence for this question, dear student, the correct answer should be option number 1. I hope you understood the solution. Now let us move to the next question.